Good day everyone. My name is Erica Jean Malabanan and today we will discuss about t-test one sample. So t-test can be used if the probability distribution is normal, sample size is small or less than 30, and population standard deviation is estimated from the sample standard deviation. The primary purpose of a one-sample t-test is to compare a sample mean to a known population mean. So here is the step in getting detailed one sample. Step 1. Constructing null and alternative hypothesis. Step 2. Identify the following: alpha, one-tailed or two-tailed, graph, tabular value, and degree of freedom. Step 3. Show the computation using the appropriate formula. Next is construct the interpretation or findings. And the last is construct the conclusion. The formula in t-test one sample is t equals mean minus population mean divided by standard deviation over square root of n, wherein u is established populated mean, mean for sample mean, s for standard deviation, and for number of samples. Let's have our first example. A study shows that the average daily coffee consumption of a 25 to 35 years old student is 4 cups per day. A university claims that their students tend to drink less than 4 cups. They selected 18 students and found a mean of 3.5 cups with a standard deviation of 1.8 cups. Use 0.01 level of significance to test their claim. Their claim is less than 4 cups. Step 1. Our null hypothesis is the students tend to drink less than 4 cups, while the alternative hypothesis is the students tend to drink greater than or equal to 4 cups. Step 2. The level of significance is 0.01. Test is t-test one-tailed. Here is the graph. df is equal to 18 minus 1 equals 17. So we use the table in getting the tabular value. So one-tailed, the level of significance is 0.01 and 17. So the tabular value is negative 2.567. Step 3. The formula is t equals to mean minus population means divided by standard deviation over square root of n, where n is 18, u or the population mean is 4, standard deviation is 1.8, and the mean is 3.5. Then substitute to the formula. 3.5 minus 4 divided by 1.8 over square root of 18 is equal to negative 1.18. Step 4. The computed t-value of negative 1.18 is greater than the tabular value of negative 2.567 using 1% of level of significance and degree of freedom of 17. Therefore, we reject the null hypothesis. The students tend to drink greater than or equal to 4 cups. Let's have another example. A recent study shows that the mean pulse rate of college women is 73. A researcher wants to know if the mean pulse rate for all college women is equivalent to 73. He measured the pulse rate of 15 college women in a certain university and found that the mean is 70.31 with a standard deviation of 8.52. Use 0.10 level of significance. Their claim is equivalent or equal to 73. Step 1. Our null hypothesis is the mean pulse rate for all college women is equivalent to 73, while the alternative hypothesis is the mean pulse rate for all college women is not equal to 73. Step 2. Our level of significance is 0.10. Next, since our sample size is less than 30, we're going to use t-test one sample two-tailed. Next is the degree of freedom with the formula of df is equals to n minus 1, or df is equals to 15 minus 1 is equals to 14. Now, let us look the 0.10, two-tailed, and the DF, which is 10. Then look at 0.10 and 10 intersect to find our t-value. So our t-value is positive negative 1.761. Step 3. Using this formula, let us substitute the given. T is equals to 70.31 minus 73 over 8.52 divided by square root of 15. T is equals to negative 1.22. Step 4. The computed t-value of 1.22 is less than the tabular value of 1.761 using 10% level of significance and the degree of freedom of 14. Therefore, we accept the null hypothesis. The mean pulse rate for all college women is equivalent to 73. A smartphone manufacturer claims that its latest model has a battery life that lasts longer than the average of 12 hours. In a test involving 26 devices, the average battery life recorded is 13.5 hours, with a standard deviation of 2 hours. Is there sufficient evidence at the 0.1 level of significance to support the claim that the new model has improved battery life? Step 1. The null hypothesis is the latest model has a battery life shorter or equal than the average of 12 hours, while the alternative hypothesis is the latest model has a battery life longer than the average of 12 hours. Step 2. T-test one-tailed 0.01 level of significance. DF is 25 and tabular value is equal to 2.485. Step 3. 13.5 minus 12 times square root of 26 over 2 equals 3.8243 or 3.82. Step 4. The computed t-value of 3.82 is greater than the tabular value of 2.485 using 1% level of significance, degree of freedom of 25. Therefore, we reject the null hypothesis. The latest model has a battery life that is longer than the average of 12 hours.